Kotlin Coroutines. So what is Kotlin Coroutines? Any guesses?
So would they be similar like Go threads, where they're just quick, very cheap threads you can spin out to run processes concurrently? Or
Exactly.
Not processes, but like, yeah.
Yeah, exactly. It's like very similar to Go routines. So I was expecting it to come up with like coroutine with K, but they didn't. So it's Kotlin coroutines then. So basically, Kotlin it is a Kotlin language feature for writing asynchronous code, and asynchronous code is a programming paradigm where operations can be executed independently of main program flow, allowing main program to continue its execution without waiting for the asynchronous operation to complete. It's like you have a main thread and you need to use non-main thread to execute some code while main thread still goes on. Okay, so what are the benefits, or why do we even write asynchronous code? Anyone?
So we can do stuff while we're waiting.
Right. Okay, so because of that, since we don't have to wait until something is done, what we can achieve is we can achieve improved responsiveness. So even if you are downloading a file or making a network call, your page can still scroll. Reduce latency. If you are making multiple calls or if you are doing multiple operations, they don't have to wait for each one to finish for the other one. Efficient resource utilization, CPU or even for the network resources, and improve scalability. This part, so this was very general benefit of asynchronous programming, but why it is more critical for Android programming? Because Android, being mobile platform, it has very limited resources. So efficient resource management is required. Then responsiveness. It's related to the first one. Since there are limited resources, we need to make sure that when we are making like so many network calls, the app is still responsive and user can scroll it or even see the spinner going on as well. Then avoid application not responding crashes. So there is a platform policy that if any operation takes way long time for finish on main thread on Android, then it will just crash with this application not responding error. Then network operations. So in order to keep main thread free for UI related operations, Android has policy of enforcing network calls only on background threads. So you cannot make a network call on main thread. And UI updates, after the background thread is done, you still need to make UI updates. So you need a mechanism where they can join and main thread can update the UI. And resource cleanup. So on Android, if you are on one screen, you go to second screen is making like 5 or 6 network calls. While those network calls are going on, and if you go back to the first screen, you need to make sure that whatever resources you occupied while making those 4 network calls, those are cleaned up. So that's why it is critical for Android. So advantages of Kotlin coroutine over alternatives. So alternatives we used to have were just use standard threading or callback. So Kotlin coroutine is concise, as Braden mentioned earlier, that good development tool can help us managing complexity. This is one of those tools. It also requires less boilerplate code, so it's easy to read and it's in sequential fashion. It's lightweight compared to threads. So we'll get to that later. You can avoid callback hell, and you also get structured concurrency. So that's all you get by using Kotlin coroutines. Okay, so code-wise, how does it look? So this was the approach or the solution we had before coroutines was this thread. This is a thread-based solution. So what we had to do was, in order to do any background work, we had to create a special class for that entire task. So you had to create a task which is derived from async task. So you can specify what it needs to do in the background, and whenever the background work is done, what result it produces, and what should be done with that result. And finally, you need to execute that task whenever you need to fetch that. So ultimately, this is the code you would have to write if you were writing a code with async task, which was like solution provided by Google earlier. With Kotlin Coroutine, this is all you need to do. So it's right there. You can see how simple and how easy to read the code is. And there are times where on Android we have to make multiple network calls, like 4 to 5 network calls in a single screen. So the difference would be very visible like this. It's like this is simply just network calls without any other logic, and it's huge. It's huge. Okay, let's dive in. So when they started with Kotlin Coroutine concept, they came up with or they advertised it as lightweight thread, but they are not really lightweight threads. What they are is concurrent operations. So even on the same thread, you can have multiple coroutines going on. So it's not really lightweight thread, but for understanding, it's okay dumb to begin with. All right. So here's our code. This run blocking is basically just to make sure that the main thread does not die before the coroutine is completed. So what happens inside is, this is the main thread going on. The first thing we are doing here is we are launching a new coroutine. So launch is a coroutine builder there. So what we are doing is, the main thread is going on. We are launching a coroutine. So what this coroutine is doing, it is delaying for 1 second. So this is comparable to sleep, but the difference is with the thread.sleep, it will block the entire thread execution. But with this delay, what it will do is it will just suspend this one particular coroutine, and thread can still going on. And then after 1 second of delay, we are printing world there. And the result here is hello world, because after launching this coroutine, the main thread continues on executing its regular flow. So it's printing hello while the coroutine is waiting for 1 second, and after 1 second it prints world. So here is the result there.
Is launch a keyword available everywhere? Is this added to the language?
No, launch is only available within a coroutine scope. So when we make this run blocking, we get a coroutine scope here. So we are inside a coroutine scope, and launch is only available on a coroutine scope. There is a global scope that is available, so you can do what you can do is global scope dot launch, but that is not recommended, because it is available everywhere and it is very hard to clean that global scope.
I'm not as familiar with Kotlin as I should be. What is run blocking? Is that a variable name? Is that a class type? What is that?
So run blocking is basically, what it does is it gives you a coroutine scope within which you can run a coroutine, and it will hold the thread until that is completed. So this is a special kind of coroutine scope that we get.
Okay. A method with a trailing closure is its only parameter.
Yeah, so basically this is a method and this is a trailing parameter which you can just called by this syntax.
Can you go back a few screens where you were doing the launch right here? The view model scope, is that a variable?
Yeah, so view model scope is available in Android's view model classes, which is specialized for, so usually per screen you have one view model. So when you go back, this is what I was talking about. When you go back, this view model scope gets cleaned up. So anything or any job that were started from this view model scope will be cleaned up.
So, so however you created that, it automatically has a coroutine scope.
Yeah.
Okay. All right.
Okay, so now suspend function. Basically, whatever we were doing here, like delaying and then printing, we can extract that out and we can call it suspend function because it is essentially suspending the execution of this this coroutine here. So it is a suspend keyword. I think it's comparable to async in JavaScript, right?
Seems like it.
Yeah.
Yeah.
So basically just the same thing. We are extracting out that functionality, and a suspend function can be called only from a coroutine. Okay, so its execution is by default it's sequential. So we have two functions here. Function 1, which takes 1 millisecond to finish before returning an integer, and same thing for function 2. It takes 1 second before returning another integer. So what we are doing here is we are taking result of first function, result of second function, and then we are just printing the sum of both. And then what we are doing is we are printing the time it took. So measured time millis is another specialized suspend function, which basically measures the execution time and returns the time there. So we are simply printing the sum of those two integers and time it took. So since it's waiting for first to finish before it starts the second function, it is taking 2000 plus milliseconds because 1000 for first, 1000 for second, and it's about 2 milliseconds, 2 seconds. So by default it's sequential, but it can be concurrent using async blocks. So these two functions are still the same. They are waiting 1 second before returning integer, but we are changing things here. What we are doing is, instead of calling that function directly, we are calling async and then calling it function as a lambda parameter. So what this does is it returns a deferred object immediately, so the execution continues. So we get a deferred, or I think it's a promise in JavaScript. You get a promise right immediately, then execution continues. You get another deferred object here and execution continues, and now here we will need its result to sum both integers. So here it will await for result 1 and it will await for result 2. Since they were already we already started their operation without waiting for first to finish, we started second's operation. It's just taking little over 1000 milliseconds. Yeah.
So that print line on 8, it knows to like wait until each 1 and 2 are finished before running the line, or while it's running the line. Once it hits like 1.await, does it wait to get the answer before moving on to the plus?
So this is a string interpolation, right? So this is still a function right there.
Yeah.
So in order to create or in order to build the result of this string itself, it needs to invoke this function, and part of invoking that function is where it will wait.
Okay,
So await is blocking.
Yeah.
gotcha.
So it has structured concurrency, which is very important for Android development at least. What it does is, it's so any coroutine can be spinned off from, can be launched from a coroutine scope. So you need to be in a coroutine scope to launch that. So that was your question earlier, is like, can you launch from anywhere? No, you need to be in a coroutine scope to launch that. And what it gives is, it allows better mechanism for completion. So here we can see that we created a job. So basically, when you launch a coroutine, you get a job object back. So we are just keeping reference of that job object, and we are printing hello, and then we are waiting. So basically, this will wait. This will make sure that execution waits until this job is done. So
Do you know why that's called join? Because we had await before, and now we have join.
So await is little bit different because it is a deferred object. You got a deferred object. So await is a function on a deferred object, where this is a job. This is a different thing, because it is entire job and not just a
So do
deferred.
you know what it's joining? Like, why does it use join?
So I think in complex scenarios, when you need to combine two different coroutines, and not necessarily, so you spin off one coroutine from another coroutine and you wanna wait for that. So I guess for that reason, I'm not particularly sure about that.
It's joining back in.
Yeah, joining back in.
Java, C++, Ruby, Kotlin, and Python all use join for the same meaning. So
The inverse of
probably
fork.
some history. Yeah, that's true.
Isn't the inverse of fork a spoon?
Comes with
And yeah, sorry.
Quick question. So like the async the async and the await, is that part of coroutines, or is that something like, is that just part of something else?
Async and await that we just talked about.
Yeah, like from a couple screens.
Yeah, it is this one.
Yeah.
Yeah, this is part of coroutine.
So you have to be in a coroutine scope to use those keywords as well?
Yeah.
Okay.
Okay, and so that was the completion part, and more importantly, cancellation. So this is very much important for Android for the reason that I mentioned. Like when you leave screen 2, whatever jobs that you have started, you want to make sure you close them. So since every job or every coroutine is attached to a particular scope, and the scope in Android we usually get from one scope per screen. So whenever you leave that screen, you can just cancel that. You can just cancel all the jobs of that scope, and you can be assured that the resources that were occupied by those jobs or coroutines will be released and won't leak. Coroutine context. So whenever a coroutine is executed, we need to execute it from a scope, right? We need to launch it from a scope, but whenever it's executed, it is executed inside a coroutine context. So a coroutine context is contains information about coroutine's job, a reference for that, and a dispatcher. So what is dispatcher? So dispatcher is the one that determines what thread a particular coroutine will be executed on. So you can specify that the coroutine needs to be confined to a specific thread or a specific thread pool, or it can run unconfined. And you can specify that that dispatcher whenever you are launching it. So launch dispatcher.unconfined default or your any particular thread. So finally, differences between Kotlin Coroutine and JavaScript async await. you guys can correct me because I'm not very much sure if this is 100% accurate, but in Kotlin Coroutine, you get structured concurrency. So, a coroutine can only be launched from a scope and those kind of things. But that is not the case with JavaScript. JavaScript gives more control to developers about how to launch them. Does that sound accurate?
I don't know, Troy.
I think so.
I think it's a pretty accurate statement.
Okay. And then cancellation. So for cancellation, it's pretty easy for Kotlin Coroutine. We have you can specify even timeout for a coroutine to expire and those things. But if you had to achieve those things with JavaScript async await, there is manual work that you have to do. And I think that's end. Questions?
Thanks. Got 8 minutes for questions. We asked for questions during the presentation. Thanks, Arch.